Hi. Okay, so I thought what we could do this evening to start us off is to have a look at some of your quiz questions that you had in the last quiz, because some of you, some of these questions seem to have caught you out a little bit. So I thought we'd look at this one and then this one. This one, it seemed you guys did not like this question about the broken pole. So we're going to do those two questions this evening from the quiz. And then if there's time, we've got one or two more, and then we're going to do one or two other things. Okay, so just like we did before for new people, let's read our question. And once you are done reading, put your reading emoji in the chat so that I can know that you are done reading. That's the reading emoji. So just let me know by posting that you are done reading. Sorry, I'll put it back on just now. Oh, nice. I see a book instead of glasses. And then Bokomos is giving us 3 different options. Come, everyone. I want to see a lot more emojis because we are about 80 people, so there should be 80 emojis here. Remember to stay on mute, everyone. It's just so that we keep the quiet of the room and we don't get irritating background noise.
I like the emoji with the one glasses thing. What is it called? Like a monocle. Like
yes.
That's my favorite. Oh, and like the tears, always the tears. Don't worry.
Where's the tears?
Don't worry, Mary.
Oh, there's the tears.
Go through it.
Yes. Okay. All right. So I went to fetch this orange bubble from our lesson when we started doing these word problems, because this is our guide. Okay. This is how we get through this. This is how we help our brain solve this problem. So a woman is standing on the ground looking up at a glider. Now, what is a glider? A glider is, I don't know if you guys have seen those, especially here in Cape Town. They jump off the edge. I don't know, anyone can do that, but they jump off the edge of Lion's Head, and then they just glide with this, it looks like giant wings, and then they kind of go on the wind, and then they land eventually. So that's what a glider is. So she is standing on the ground looking up at a glider, and the angle of elevation of the glider, according to the woman on the ground, is 48 degrees. If the glider is 2,340 meters from the woman, calculate the altitude. Now, what is another word for altitude? Another word for altitude is height. Okay, so our first step is always to visualize. So picture this woman looking up at this glider, and now once we've pictured it, we can visualize. And after that, we can start drawing. So your next job now is to make a little sketch of the situation. So picture your glider, picture where the woman is, and remember we are going to figure out. Oh, someone's got the answer already. Okay, don't post answers. Please just wait with answers until we are all able to post and we've all had a chance to do it. Well done for being so quick with it, but let's just hold answers. It's all good, don't worry. So as I was saying, let's make a sketch. Let's make a drawing of what this situation looks like. And I'm going to give you about a minute for that until 1718. And if you're happy with your drawing, label your sides, label your angles, check everything is right, and then solve using your correct trigonometric ratio. Zochli, I'm going to ask you to just hold your question until in a little bit, okay? I'll give you a chance in about 3 minutes. Just put your hand up again and I'll give you a chance to ask then. Okay, so let's think about this. Here's the woman. I'm going to draw this person here. This is a woman, believe it or not. And she is looking up at the glider. So the glider is over here. I'm just going to make a dot there because I have no idea how to draw a glider. And we're going to just call it, that's the glider. And the angle of elevation, according to the woman, from where she is to where the glider is, that angle of elevation is going to be 43 degrees. So we make a triangle, we show our 43 degrees, and then the altitude or the height of the glider is going to be this side. And if the glider is 2,340 meters from the woman, so that is the distance between the glider and the woman, that's 2340 meters. Okay, so check that your sketch is right and that you've put the correct angle and the correct distance and that it looks more or less like my one. And now we can use our trigonometry to solve. Which trig ratio are we going to use to solve for the height? And I'm actually just going to change it so that we don't get confused with height and hypotenuse and all of that. So I am going to call it A for altitude. Which trig ratio are we going to use? Sine. Wonderful. You guys have come a long way since our first lesson. Lots of you are knowing. Yeah, so Ayanda, I changed the H rather to an A because H could also mean hypotenuse, so I don't want anyone to be confused. Okay, good stuff. And we use sine because it's the opposite and the hypotenuse. So this is my opposite side, this is the hypotenuse side, this is the adjacent side. So sine of 43 degrees is equal to A, the altitude that we are trying to solve for, and the hypotenuse side 2340. Okay, and now we can times by 2,340 on both sides. So sine 43 times by 2340. And post your answer in the chat if you've got it. What do you get? What is the height of that glider? You can post it in the chat if you've got it. Let's put some answers down, guys. There's about 80 of you. Like I said, how many are we now? It's almost 90. So we need lots more answers. Work it out. Remember what I said at the start about participating? You got to get going. Yes, you can screenshot this the sum. Okay, Portia saying 1595. Lots of 1595 is coming through. Okay, so we have to round to 2 decimal places, and I agree it's 1595,88 if we round to 2 decimal places. Okay. We normally do 2 decimal places unless, yeah, the question didn't say, so 2 decimal places. That's the right one. Okay, well done, everyone. That was our warm-up round, and it's from your last week's quiz. So I don't know if you remember it from then, but I hope that is the answer you got and that you got full marks for that one. Anyone wanting to take a screenshot can do that right now, before we go on to the broken poll question that seemed to have everyone stumped. Okay, let's go. Same thing. Read the question, post your reading glass emoji in the chat. Let me know when you are done. Okay, so if you have read, as soon as you've read, start making a plan. How are you going to solve this question? We must do the difficult things as well so that we can challenge ourselves and grow. And this one's actually not so difficult. It is just a little bit of logic. So as soon as you're done reading, start working on your plan. How are you going to solve this? Okay, so a flagpole PQ broke at point R after a strong wind. This resulted in the top portion of the pole PR forming an angle of 60 degrees with the ground at P dash. Now 15 meters away from Q. Okay, so again, let's visualize what happened from the words and from the story that's written here. Broken pole, strong wind, it broke at point R, and then it fell to the ground, and now it is basically lying there at point P dash, 15 meters away from point Q. Calculate the original height of the pole. Now, I don't want to say too much because I want to hear from you guys. What do you think? Who's got any ideas? How will we solve this? Who wants to tell us? Any ideas? What do you think? Hi, Bokomoso, Bukhle, and Nbenkle all have some ideas. Let's hear Bokomoso.
Hi, ma'am.
Hi.
Yeah. Okay, so I'm not sure about this plan because last week I got it totally wrong and I'm questioning my intelligence. But according to what I'm seeing, I think that probably maybe we should use 10 because yeah. Yeah. Yeah, I don't know.
Okay.
I think we should use it.
Okay, so we've got a suggestion to use tan to calculate which length?
In order to calculate the PQ length. Like the way I am understanding this is that the pole was broke. So seeing that it broke, we need to find the total length. We're looking for
Yes.
that side. So
Yes.
aren't we gonna use 10?
Yes, okay. I think what you mean is that we need to use tan to calculate RQ. Well done. Okay. Bukhle, have you got anything else you want to add?
Ma'am, I was thinking that we, like Buganusa said, that we use 10 to solve QR, and then
Yes.
from there we use cos to solve for RP, and then we add the totals together to get PQ.
Okay, wonderful. I like that thinking. Well done. And Benkle? What do you think? Anything you want to add?
Ma'am, I think we use tan to find RQ and then just use Pythagoras.
Excellent. Second option, yes. With these trig problems, there's always more than one way to do it. Okay, so we've heard some really good ideas now. Thank you to Ndabenhle and Puthle and Bokamoso. Miss Courtney, I don't know who this person is.
Sorry, I'll chat to them and ask to rename.
Okay, thanks. Yeah, so thanks to those guys who shared their thoughts with us. So let's get going and see if we can solve this problem. Okay, so we said remember from our previous lesson as well, for those of you who were here and those of you who are going to watch the recording to catch up, PQ is equal to 2 lengths, PR plus RQ. And we did that last time as well, where if we had to break up a distance, then we could say that there's 2 distances, and then we solved for the one and then solved for the other one. So we're going to start by solving for RQ. And RQ, we can say, if we look at the 60 degrees, that's the opposite. That's the hypotenuse. And that is the adjacent. Okay, so we're going to solve for RQ. And then we can either use cos or Pythagoras to solve for RP dash. RP dash is this new distance after the pole broke. So I'm going to give you about 4 minutes to do that, because I really want everyone, as a last sort of challenge in this course on 2D trigonometry, to really give this a go and do your best. We have discussed now how we're going to do it, so I'm going to give you 4 minutes and you give it a go. Okay, thanks Nabenhle, that is excellent. Let's give everyone else a chance quickly, and at 17:34 we're gonna check back. Yes, Bokamoso, you have your hand up.
Yes, ma'am. I was just about to say, okay, I understand using the trig ratio, it will work. But then ma'am mentioned the whole Pythagoras option. Now, my question is exactly how are we going to be able to use the Pythagoras method, because we only have one side? Don't you need about like at least 2 sides in order to use Pythagoras?
Yes, that's absolutely right. So that's why you solve for RQ first. So RQ goes first, and then you can use Pythagoras.
Okay, makes more sense. Okay, no problem.
Okay. Can just hear everyone's brains going and thinking. Okay, for those of you who are done, check your work. Always check that you've done it correctly. Check and go through it. Make sure you are happy with your answers. Oh, I'm sorry to hear that, Nompumelelo. I know this electricity business is just a challenge for all of us. So just do what you can, and the recording will be available afterwards, so you can watch it again afterwards.
Just want to say to some of you who have been very quiet this lesson, please feel free to send any questions in the chat. You can send them to me personally as well if you don't want everyone to see it. And send some emojis so we know how you're feeling. Don't sit there quietly by yourself. Let us help you.
Yes. Like we said, this is a warm, kind, friendly space, so you don't have to be worried about anything. And most of all, maths is about participating. Just try something, even if you're not sure it's going to be right. Sometimes it's right. Most of the time it's right, actually. So trust yourself. Just give it a go. Okay, so I've worked out that RQ is 25,98. And now I'm going to work out what the hypotenuse side is, RP dash. I'm going to use cos. You are welcome to use Pythagoras. I don't like Pythagoras. It takes too long. This is just much quicker. So adjacent over hypotenuse for RP dash. And then we multiply by RP dash on both sides. And divide by cos 60 to get RP dash by itself. So 15 divided by cos 60. Oops. Is actually 30. Okay, so your total for PQ, the length of the pole, is 30 plus 25,98, and altogether that's 55,98. Okay, please put in the chat a thumbs up if you worked it out and you got it wrong. Oh, right, not wrong, but right. Thumbs up. And a thumbs down if it didn't work out for you this time. Let's see. Thumbs up. Well done. Okay. So, for those of you who are getting it wrong or part of it wrong, please ask a question. Let us know what it is that you're wondering about. We want everyone to get this right. I see a few thumbs downs here. So let me know which part. I wonder if someone can tell us. Tegofatso, which part did you get wrong? Liachluma, which part? Let me know what part you want me to go over again.
Teacher Marilise, I was asked, someone just wanted a refresher on why you used tan at the beginning, why you chose tan.
Okay, so why do we use the trig ratio that we use? Okay, and we've done a bit of that. We've done this in every lesson. We use the trig ratio that the side that we are calculating, the one that we don't know the value of, and the side that we do know the value of, that combination, that is the trig ratio that we use. So for the first question, we use tan because, and that's why you have to label your side, which is the opposite, which is the adjacent, which is the hypotenuse. You make the ratio using the side that you have and the side that you want. So it's for 60 degrees. So the opposite side was RQ and the adjacent side was 15. And opposite and adjacent together, that is tan, TOA. And then sine, we would use sine if it was the opposite and the hypotenuse, if it was in that combination. One must be known, one must be unknown. It can only be one of those, sine, cos, or tan. Cos we used for the second part because the adjacent side is known and the hypotenuse side is the one that we are solving for. So that's why it's cos of 60 is 15 over RP dash, which is the one we wanted to solve for. So I'll say again, to solve for RQ, we are going to use tan RQ over 15 because that's opposite over adjacent. Opposite side and the adjacent side. Okay, so you must know your SOHCAHTOA for this. You must know which sides go together to make the trig ratio. And then we use cos 60 for the last one because that's adjacent, 15, and hypotenuse. Okay, to solve for RQ, we're going to times by 15 on both sides, and that gives us 15 times tan 60 is 25,98. Second part, we times by, when we have cos 60 is 15 over RP dash, we times by RP dash on both sides, and we then divide by, so I did, there's a step here that I didn't write, but it's basically just going 15 over cos of 60, which gives us 30. Okay, so silly mistake on the first calculation. Okay, well done, Uncle. You found your mistake. Rangani, I've just gone over the second part, so I hope that is much clearer now. And then Asande says, I got the RP answer, but the RQ length did have me struggling, but I see my mistake. Okay, wonderful. We must, only my PQ was wrong. Okay, so your final calculation. Okay, so always check, and check again. Okay. Right. ASTC helps. I'm not sure what ASTC is, Nompumelelo. How do you know when you have to divide or multiply? It all depends on if your side that you're solving for is at the top or at the bottom. So if it's at the top, you're going to multiply by the 15. You're always multiplying by whatever is at the bottom. And if it's like here with the cos 60, 15 over RP dash, we need to solve for the RP dash. So we times by it on both sides. Because what I do on one side, I must do on the other side. It's like an equation. And then we divide by the cos 60 to get the RP dash by itself. Okay, so that was a lot of that we did in lesson 1 and in lesson 2. So if you are new or if you are forgetting, then go back and have a look at our recordings and the quiz from lesson 2, because the whole of lesson 2's quiz was on that. Okay, Georgia Lynn, you have a question.
Sorry, ma'am. I meant to put down my hand because you answered it for me.
Okay. And then
Thank you.
Ayanda.
Hey, ma'am.
Ayanda, you have a question? Yeah.
No, ma'am, I think I got it. You've just explained.
Good. Well done, Kineleu. That's great.